Hey, hi. So I'm Parag, and in this particular project, what we'll be doing is so you have matrix A, which is 2000 to 2000 matrix, and we have vector B, which is 2000 to 1. Now, what we'll be doing is that we'll be multiplying these two. We'll be doing a matrix vector multiplication, and we'll be doing it almost 20,000 times. And we'll be measuring the computation time in four different scenarios. So the first one being GPU with single precision, second one being GPU with double precision, CPU with double precision, and fourth being GPU with single precision. So this is the method we'll be going ahead with, and I'll be showing you in my screen. First, I'll show you the code what I've written down, and then I'll explain the code, and finally, what I'm going to do is that I will run and I'll show you running the code by myself. So yeah, so let's start off, and let me share my screen right away. Just a minute. Let me share my screen. Okay, so I think I think we are into the screen. Okay, so I would explain everything, all of this, when I do it one more time when I'm actually writing the code. I'm explaining my first code that I've written down in MATLAB, the MATLAB code. So this is the MATLAB code that I've written. And in this particular MATLAB code, what I've done in particular is that uh, in here you can see that one thing is, so this is the steps. Okay, so these are different steps that I've written down. And in the first step, if you can observe, so we have a matrix A, which is almost 2000 matrix. The matrix B is 2000 into 1. It's a vector. It's a vector. And the rand function in MATLAB is used to create arrays with random values between 0 and 1. Okay, and then we multiply them a lot. Okay, we almost do it almost 20,000 times, and really performing the matrix vector multiplication in various scenarios for these many iterations. And we are doing the math in a lot of different ways. Okay, so we have different scenarios that we've taken: CPU with single precision, CPU with double precision, GPU with single precision, GPU with double precision. And in this, if you look in here, for example, let me start off with the let's say scenario one. Okay, so CPU with single precision. Okay, so you can see that this loop calculates the matrix vector product using single precision. The tick and tock functions are used to measure the time it takes to execute this loop, and the result is stored in the CPU single time. Similarly, for scenario 2 with CPU with double precision, the timing is stored in CPU double time. Okay, and yeah, then GPU with single precision, you can see that it is again stored in GPU single time. And for the GPU scenario 4, it has been stored in GPU double time. And in this, finally, in the F print, what we have done in this, when I ran the code ahead previously, was that we have, you can see that, there is a, we print out these execution time for each of these scenarios. The %4.f in the fprintf function is used to, used to format the output, displaying the time with almost 4 decimal places. This allows the user to compare the efficiency of matrix vector multiplication across different scenarios and precision times on both CPU and GPU. So this is the explanation of the entire code, and now I will go ahead and actually do the entire code by myself from starting to end and show you how to go about doing it. So I'm going to open another terminal, another shell. So I would start off with entering my student credentials, which are quite important. So you can see here, and now it's gonna ask for my password. Okay, and I hope you remember, in here in Kani, you can't see your own password for security reasons. So I'm now right now in the my student portal, in my student Kani. Okay, a number. Now I'm going to use the this particular command which has been given to me by my professor. So what that does is that it gives me access to one of the nodes to use GPU in Kani. So I ran this particular command, and now it says that I've been allotted node 16, which is a good thing. Now I'm gonna open MATLAB in this. So to do this, I'm gonna module load MATLAB, and I'm gonna do MATLAB. Okay, so MATLAB is opening up, and yeah, let's see MATLAB to start off. Okay, and hmm, so I'm gonna paste the code, which uh, I have copied from there, and from the another terminal itself. Okay, and it will take us around 3 minutes for us to the code to actually run. It takes a while, so then I can show you to the output. Yeah. Hmm. Okay, so then we have something. Okay, we have something here, and yeah, let's see. What do we have here? Okay, so we have the output, and it has been ranked from the fastest to the lowest. So you can see the GPU double precision is the fastest. It's 1.9799. GPU single precision is 3.0821, while CPU double precision is 41.96, and CPU single precision is 104.4590. So I think so. That was great. So I think that was the um, measuring computation time, and I hope you guys enjoyed the video. And anyways, have a good one and take care. Thank you.